Yes, we are going to start now. Adjoint and inverse of a matrix. So what is adjoint of a matrix? Let's see the definition and then we'll apply that to an example. Okay. So adjoint of a matrix of a given matrix is the matrix that results from transposing the cofactor matrix of matrix. So far we understood how to find the cofactors, right? We also saw an example where we found the cofactor matrix itself. What is cofactor matrix? Writing all the cofactors in the corresponding position, that becomes cofactor matrix. And then transposing that. Why these many steps? Because there is a very significant application of this. That's why these many steps we need to understand. Okay, so using all these, we can be finding the inverse of a matrix easily, but we have to be very careful while solving them, right? All these steps are included in finding inverse of a matrix. Okay, so what is adjoint of a matrix? Adjoint of a matrix is a matrix that results from transposing the cofactors matrix. Okay, so there is an example here, 2 cross 2 matrix. Let me take that, 2 3 4 9. So what is the cofactor matrix of this? Cofactor matrix of R, cofactor matrix of R will end up with, what is the cofactor of this number? 9, but it is first row, first column, so it's going to be plus 9. And what is the cofactor of this? It's going to be minus 4, right? Cofactor of this will be minus 3, and right? Yes or no? And what is the cofactor of this matrix? It's going to be, this element is going to be plus 2. This is cofactor matrix, but this is not adjoint. What we should do, we have to take the transpose of this. Transpose is nothing but what? Transpose of matrix. Go back to matrix part. Transpose is interchanging the rows and column. So that means if we have got A11, I mean, if we have got A11 of this matrix is 9, A12 is minus 4, A21 is minus 3, and A22 is 2. So A11 remains 9 only, A22 remains 2 only, whereas A12 will be interchanged with A21, so it becomes minus 3, and this will become, A22 will become, 21 will become minus 4. That is its transpose, simple, as simple as that. So there is 9 here, this will become minus 4, this will be minus 3, this will be 2. This is adjoint of the given matrix. Okay, so try to understand. Adjoint of a 2 by 2 matrix is always easy, less time consuming. But in case of 3 by 3 matrix, it will be little time consuming. And there is a lot of places where you can make simple errors that may lead to the wrong answer eventually. Okay, so let us actually try to look at one of the 3 by 3 matrix to understand how tedious this can go. At the same time, how carefully we can get the adjoint of a 3 by 3 matrix. Shall we? Shall we go ahead? Yes. Thanks for replying. So let's go to the next one. That is 3 by 3 matrix. Yes. Let me take a simple example. Better here. A simple 3 by 3 matrix. I'll take 1, 2, 1, 3, 1, 3, 1, 1, 4. Let's take this matrix. I want adjoint of this matrix. Can we quickly find out the cofactors? Let's not waste much of the time now, but at the same time, we should not make errors. So that's a simple rule. It may not be simple if you don't practice. Okay, practice makes it simple, right? A22, A23. What is A11? So it's going to be plus sign, and 4 minus 3, which is 1. A22, it's A12 minus sign. Eliminate the second column, first row, 3 4s are 12, 12 minus 3, 9, minus 9. So that is here, minus here, A12 is here, right? A13, what is A13 then? This one, right? So first row, third column, eliminate the first row, third column. It's going to be plus sign and then 3 minus 1, 2. Okay, coming to second row, first column, eliminate this completely. Second row, first column, eliminate the second row, and the first column, 2 4s are 8, 8 minus 1, 7, but minus 7, right? A22 plus symbol. So first, second row, second column, 4 minus 1, 3, and A23, that is third column, second row, it is going to be minus sign, 1 minus of minus 2 becomes plus 2. So quickly, A31, A32, and A33 we're going to find. See, now I have to be very careful. It's better double check it while writing the signs and as well as numbers. No doubt, no problem. Instead of doing the entire column again, that will be time consuming, right? So third row, first column, I'm going to eliminate third row, first column. So 3 plus 1, 4. So it's plus sign. 3, 6 minus 1, 5. Okay, A32. This is the element. I have to eliminate this column, second column and third row. 3 1s are 3, minus 3 0. So that means it's going to be 0, whether it's plus or minus doesn't matter. Last one plus 1 minus 6, which is minus 5. So I end up with minus 5. So what is our cofactor matrix? Our cofactor matrix in that order, plus 1 minus 9 plus 2. Right, cofactor matrix. Next, I have second row, first column, which is minus 7 plus 3, and then we have plus 2. Yes. And the last one, third row, first column, 0, and then minus 5. This is not adjoint. Transpose of this is adjoint. What is the transpose of this? Plus 1 minus 9 plus 2 minus 7 plus 3 plus 2 5 0 minus 5. So this is our adjoint of the given matrix. If I call it as A, this is adjoint of A. Okay, I know it is time consuming, but we don't have a choice. If you want all the answers, all the numbers to be right, we have to do it slowly. Right? Yes. I hope this is clear now, so we can easily find adjoint of any matrix, whether it is 3 by 3 or 2 by 2. And don't worry, we don't have questions on 4 by 4. Singular matrix. What do you mean by singular matrix? There's a theorem which talks about singular matrix. The theorem which says a n by n square matrix, that is n by n itself means square matrix, right? Because the order of number of rows and columns are equal to each other. A is said to be a singular matrix if the determinant of A is 0. If you find the determinant and if that determinant is 0, it's called singular matrix. Okay, there's an example. What is the determinant of this matrix? 4 minus 4, 0. It's an example for 2 by 2 singular matrix. And there's an example for 3 by 3 singular matrix. And we know that if any particular row or any particular column is equal to another row or another column, automatically determinant becomes 0, right? So that is also one of the elementary properties of determinants, which is not in our syllabus, but still remember this point. If the entire row or entire column of a matrix is equal to another row or another column of a matrix, then definitely the determinant will become 0. Okay, on that basis, without even solving, I can tell this all these 3 rows are identical with each other. Okay, and 2 columns are identical with each other. If I take 1 common from each of them, this entire element will become 1 1 1, right? So that is why this determinant is 0 and it is a singular matrix. Okay, another example, see, 2 9s are 18 minus 3 6 are 18. 18 minus 18 is 0. So it is very important to understand singularity of a matrix. If it is singular matrix, what happens? What is the consequence? If it is non-singular matrix, what is the consequence or what is significance of checking this singularity? We'll see in the next part. Okay, that is. So here non-singular. What do you mean by non-singular? If the determinant of that matrix is not equal to 0, it becomes a non-singular matrix. Here are some examples which you can check later. Let's move on to the next one. What are we doing with the singularity and adjoint of a matrix? Okay, there is a theorem. So the theorem states if A is a given n by n square matrix, then okay, so you can keep it as X. If X is a square matrix, then X into adjoint of X, if you multiply them in any order, adjoint of X into that X, both of them will be equal to determinant of that matrix into I. Okay, so we have discussed in the matrix class, if a product of two matrix in any order is equal to identity matrix, then each of them are inverse of other. So A is inverse of B, right? Or B is inverse of A, right? So same way, if I want to bring that principle here, so I'm going to modify this a little bit. X into adjoint of X, if that is equal to determinant of X into I can bring that determinant here to the denominator, because determinant is a real number, I can easily bring it. Now what happens is this is a matrix X and this will be another matrix. So if the product is equal to I in both the orders, right? You can write it other way around also, because we have another equation. I can put the inverse here also. I mean, I can put the determinant here also. So then what happens? This into X or X into this expression is equal to an matrix. That means that expression must be equal to what? Inverse of a matrix. And now do you understand why singularity is important? Because if the determinant is 0, we won't be able to understand the value if that value comes in the denominator. So that is the reason, if the determinant of a matrix is 0, it's a singular matrix and it will not be having an inverse. Inverse doesn't exist. So when inverse doesn't exist, if the determinant of a matrix is 0, that is singular matrix. So only for the non-singular matrix we can find the determinant, right? Yes or no? Yes. So, and you know how to find adjoint already. We're going to use that. So let me erase all this. There's one more important statement here. Since the sum of the product of the elements in a row or a column with the appropriate cofactors are equal to determinant A and is otherwise 0, we have this. There's an example here. If this is cofactor of 1 and 1, so if all the other non-diagonal elements are 0, 0, 0, then what we can do is we can take this example directly. Adjoint of all the other values are 0, only the diagonal elements have the values. Okay, then we can take that value common if they're all equal, and if we take that value common, so we'll be having an identity matrix. So it is also equal to this. There's a proof of this statement. Okay, if you want to understand this proof in detail, you can check this, or else let's just remember this product adjoint of a matrix into the matrix in any order you multiply. Okay, that will give you what? Determinant of a matrix into I. Because of this, we can say inverse of a matrix is adjoint of that matrix divided by determinant of that matrix. So this is the formula to find the inverse of a matrix. Singular matrix. What do you mean by singular matrix? There's a theorem which talks about singular matrix. The theorem which says a n by n square matrix, that is n by n itself means square matrix, right? Because the order of number of rows and columns are equal to each other. A is said to be a singular matrix if the determinant of A is 0. You find the determinant, and if that determinant is 0, it's called singular matrix. Okay, there's an example here. What is the determinant of this matrix? 4 minus 4, 0. It's an example for 2 by 2 singular matrix. And there's an example for 3 by 3 singular matrix. And we know that if any particular row or any particular column is equal to another row or another column, automatically determinant becomes 0, right? So that is also one of the elementary properties of determinants, which is not in our syllabus, but still remember this point. If the entire row or entire column of a matrix is equal to another row or another column of a matrix, then definitely the determinant will become 0. Okay, on that basis, without even solving, I can tell this all these 3 rows are identical with each other. Okay, and 2 columns are identical with each other. If I take one common from each of them, this entire element will become 1, 1, 1, right? So that is why this determinant is 0 and it is a singular matrix. Okay. Another example, see, 2 9s are 18 minus 3 6 are 18. 18 minus 18 is 0. So it is very important to understand singularity of a matrix. If it is singular matrix, what happens? What is the consequence? If it is non-singular matrix, what is the consequence or what is significance of checking this singularity? We'll see in the next part. Okay, that is. So here non-singular. What do you mean by non-singular? If the determinant of that matrix is not equal to 0, it becomes a non-singular matrix. Here are some examples which you can check later. Let's move on to the next one. What are we doing with this singularity and adjoint of a matrix? Okay. There is a theorem. So the theorem states if A is a given n by n square matrix, then okay, so you can keep it as X. If X is a square matrix, then X into adjoint of X, if you multiply them in any order, adjoint of X into that X, both of them will be equal to determinant of that matrix into I. Okay, so we have discussed in the matrix class, if a product of 2 matrix in any order is equal to identity matrix, then each of them are inverse of other. So A is inverse of B, right? Or B is inverse of A, right? So same way, if I want to bring that principle here, so I'm going to modify this a little bit. X into adjoint of X, if that is equal to determinant of X into I can bring that determinant here to the denominator, because determinant is a real number, I can easily bring it. Now what happens is this is a matrix X and this will be another matrix. So if the product is equal to I in both the orders, right? You can write it other way around also, because we have another equation. I can put the inverse here also. I mean, I can put the determinant here also. So then what happens? This into X or X into this expression is equal to an matrix. That means that expression must be equal to what? Inverse of a matrix. And now do you understand why singularity is important? Because if the determinant is 0, we won't be able to understand the value if that value comes in the denominator. So that is the reason, if the determinant of a matrix is 0, it's a singular matrix and it will not be having an inverse. Inverse doesn't exist. So when inverse doesn't exist, if the determinant of a matrix is 0, that is singular matrix. So only for the non-singular matrix we can find the determinant, right? Yes or no? Yes. So, and you know how to find adjoint already. We're going to use that. So let me erase all this. There's one more important statement here. Since the sum of the product of the elements in a row or a column with the appropriate cofactors are equal to determinant A and is otherwise 0, we have this. There's an example here. If this is cofactor of 1 and 1, so if all the other non-diagonal elements are 0, 0, 0, then what we can do is we can take this example directly. Adjoint of all the other values are 0, only the diagonal elements have the values. Okay, then we can take that value common if they're all equal, and if we take that value common, so we'll be having an identity matrix. So it is also equal to this. There's a proof of this statement. Okay, if you want to understand this proof in detail, you can check this, or else let's just remember this product adjoint of a matrix into the matrix in any order you multiply. Okay, that will give you what? Determinant of a matrix into I. Because of this, we can say inverse of a matrix is adjoint of that matrix divided by determinant of that matrix. So this is the formula to find the inverse of a matrix. Yes. Can you check this question quickly? You have to you have to show this inverse of this matrix, and this matrix is a 2 cross 2 matrix. This has to be easy for you, right? So please try this question. I'll give you say 20 to 30 seconds. As it's a 2 cross 2 matrix, we can easily find this, and we have to find the inverse. To find the inverse, I'll just give you the clue. What you should do: find the adjoint first. Okay, and the adjoint of M you find, and determinant of M you find. Then M inverse will be what? Adjoint of M by determinant of M. So quickly do this. So what do we have? I'll tell you how to find adjoint quickly. What is adjoint? We'll repeat again. Adjoint of the matrix is what? Transpose of cofactor matrix. So what is the cofactor of 2? Cofactor of 2 is -2. And cofactor of -2 is 2, right? What is cofactor of 3? -5. Cofactor of -5 is going to be -3. Am I right? So it has to be very quick. So what is the cofactor of this? I mean, what is the adjoint of this then? Transpose, right? -2, -5, -3, +2. Okay. So before that, I should have found the determinant of this matrix. Determinant of this matrix is -4. What is it? -15. Am I right? Yes. -4 -15 is -19. Are we right? Yes. So now I want to find M inverse. M inverse is adjoint of this matrix divided by M inverse. What is adjoint of this matrix we have got here is -2, -3, -5, 2. This has to be multiplied by what? 1 by -19. So when you divide by 1 by -19, we end up with 2 by 19, 3 by 19, 5 by 19, and -2 by 19. So if we take 1 by 19 common, what we get is the given determinant itself, right? So it's clearly proved this matrix is nothing but M. So that means LHS has been equated to RHS. So adjoint of M inverse is equal to 1 by 19 of the given matrix. So hence proved. So it was very simple because it was a 2 by 2 matrix. So this same question, if they ask you 3 by 3, same procedure, but it will have a longer calculations. It might lead to a lot of errors as well, as we have too many sign changes. So let's see if we have any question like that. Find the inverse of M. I was just now telling, right? So we have to find the inverse of this. First you find the determinant of M. Let's see, which is the easiest row to start with. I can go with the first row itself. 2 into -1 into 1 is -1 plus 0, -1 into 4 plus 0, right? And 3 into 4 to the 8 plus 7, if I'm not wrong. Is that no? Is it right? So 4 to the 8, 8 plus 7, yes. So now what is the determinant of this? 2 minus 1 plus -1 into 4 plus 15 3 is a 45. I am ending up with -2, -4, plus 45. What is 45 minus 6? 39. So correct, 39 is the determinant of this matrix. Okay, so now we have to find the cofactors or adjoint. Directly I'll go for adjoint of this matrix, which is transpose of its cofactors, right? What are the cofactors? What is cofactor of 2? It's going to be -1. Yes, -1. And cofactor of 1 is 4. It's going to be -4. Why? Because of the place. It's going to be its first row, second column. So 1 plus 2 is 3, right? So again, we are going to put plus sign here, and it's going to be 4 2s are 8. 8 plus 7, 15. But it is the first row, third column. It's going to be plus itself. So it's going to be simply 15. 4 2s are 8 plus 7, 15. Next, what do we have? Second row, first column, it's going to be minus sign. Minus into 1 into 1, it's going to be plus 1 now. And here it's plus sign. 2 1s are 2 plus, 2 1s are 2 plus 21, which is 23. Okay, so finally, this we're going to eliminate third column and second row. So, and it's minus sign, obviously minus sign. 2 into 2, 4. 4 plus 7, 11, but minus 11. Last column, last row, and first column. Last row, first column. We're going to remove this 7, and it is 0. Minus of minus plus 3, but it has to be minus because of the place. It is 3, and then 1. So 3 plus 1 is 4. It's going to be plus 3 only. Then here we're going to have negative side, minus. Eliminate the second column, third row. It is 0 minus 12 to become plus 12. Finally, this is going to be plus again. We're going to eliminate the third column and third row. It is minus 2 minus 4, which is going to be minus 6. At the end, it's going to be minus 6. So transpose of this. So M inverse will be 1 by 39 into transpose of this. That is minus 1 minus 4. 15 plus 1. If all the calculations are right, this has to be the right answer. So if you divide all of them, we'll get the inverse. You can divide or keep it as it is in the common value outside the determinant. Okay, minus 4 by 39, minus 23 by 39, and so on. Okay, so that is your. Okay, let me finish this writing. This is plus 23 by 39, 15 by 39, minus 11 by 39, and minus 6 by 39. This is your inverse of the given matrix. Okay, so let us go to the next question quickly. Question number 3. I hope you copied this or took the screenshot of it. If you're writing it down, quickly finish it. Let's go to the next part. Yes. Okay, so we have to prove this. How do you prove this? So we have to be very careful. I am given with A 3 7 2 5. I'm given with B 6 8 7 9. So I have to find AB first. So this is going to be little okay because it's 2 cross 2 matrix. Okay, when you multiply 2 cross 2 and 2 cross 2 matrix, you end up with again 2 cross 2. So inverse of that is also not a problem. But if it is a 3 cross 3, the same question will be most tedious question. So you can avoid solving them in the exam if you have other option to choose a better simple question. Or else, if there's no other choice, you have to do that as well, right? What is the product of this? First row, first column, 3 6 are 18 plus second row, second column, 7 7 are 49. Okay, 3 8s are 24 plus 7 9s are 63. Can you recall product of two matrices? 2 6s are 12 plus 5 7s are 35 and 2 8s are 16 plus 5 9s are 45. So what is our AB then? Value for AB is 18 plus 49, which is 63, and then this is 87, this is 47, and this is 61. That is AB. Now our job is to find out A inverse. So for A inverse, I have to find adjoint of A and determinant of A. So determinant of A is simple. 5 3s are 15 minus 14, 1. It's a non-singular matrix. Okay, so what is adjoint of A? That's a tedious task, right? First you have to find the cofactor and its transpose, right? What is the cofactor of 3? 5. Cofactor of 5 is 3. This is minus 7 minus 2. So what is A inverse? A inverse is going to be transpose of that, right? 5 minus 7 minus 2 plus 3. So just remember this. Similarly, I have to find B inverse. I'll write B inverse here. B inverse is transpose of its adjoint divided by the transpose of its cofactor divided by B. Let me write this. Adjoint of B, right, divided by determinant of B. What is determinant of B? Let's see. Determinant of B is 6 9s are how much? 54 minus 56, which is minus 2, right? And adjoint of B or transpose of the cofactor. So cofactor, this becomes 6, this becomes 9. Okay, this is interchange, right? So what is the cofactor of 6? 9. What is the cofactor of 9? 6. This is minus 7, this is minus 8. So far everything is fine. And what is the transpose of this? Transpose of this is 9 minus 7 minus 8, 6 divided by 2. Okay, so now we have to calculate B inverse into A inverse. So this has to be 9 by 2 minus 4 minus 7 by 2 plus 3. So this is going to be a lengthy process. So let's see if you can get the product. After that, you have to find the inverse of this as well, right? So AB inverse is going to be a very tedious process. So I'll show you the solved example already in the answer so that I don't have to write all of them here. So you can just observe the steps. So far we have got B inverse individually and A inverse individually. Then we'll see the product in the solution. So I can erase this. I'm assuming I can erase this, right? Yes. See, the process has become very tedious. So we have got A inverse. There's A inverse just now we found 5 minus 7 minus 2 3, and B determinant we have got, cofactors of B we have got, and inverse of B also we have got. After that, this I just explained, and the product of that B inverse into A inverse has been solved here, and we have got some answer, and that answer should be equal to AB inverse. AB inverse has been solved here. Okay, so I'm just showing you the explanation so that we don't have to waste our time in solving this. If we know the steps, we can do it in the exam as well. So I'll be taking the advantage of online class where we have the solved example already, so we can just see the steps carefully instead of writing them. Unlike an offline class where we have to write everything and see, we already have this solution ready, so we can just check it to save the time. Okay. Yes. Any issues, any doubts, you can check the solution and let me know in the chat if you are having any issues. So assuming you have checked it, I'll be moving on to the next question. So we are left with one more concept, finding inverse. So finding a solution of a matrices or linear equations by applying determinants to the matrices. That's the last part of this class. So we'll quickly go there. So it's a 2x2 matrix. Easily we can find the uh, adjoint first. What is the adjoint of this given matrix is? What is the determinant of this matrix? Let's assume this as A. So determinant of this matrix is 4 2s are 8 plus 3, which is 11. So inverse of this matrix is adjoint of this matrix divided by this, right? So our determinant is 11. Let's look at the cofactors matrix and then transpose of that. So cofactor of this is 4, this is 2, this is minus 3, this is plus 1. So transpose of this is again what? 4 minus 3 plus 1, 2 divided by 11. So what is the inverse of our given matrix is 4 by 11, 1 by 11, minus 3 by 11, and then 2 by 11. So what is the significance of inverse? If you multiply that with if you multiply this matrix with A, you will get an identity matrix. What is identity matrix? This is identity matrix. You can check this later. So that is why this is the inverse of the given matrix. Okay. Yes. Moving on to the next one. Yes, there is an interesting question here, which is not same as the previous questions. With this, I'll move on to the next section of this class and the last and the very interesting part of this class. Okay, so let X be 3x3 matrix and 10Y be another matrix which is given here. In that there's a missing value alpha. If Y is the inverse of matrix X, so Y is the inverse of matrix X. So this must be equal to what? Adjoint of X divided by determinant of X, right? So if you find this first, we can proceed. We have to find the value of alpha. After that, whatever comes, we are going to multiply this with 10 and then equate it to this matrix, and the corresponding value will give you the alpha. That is the process. I'll repeat again. They are told Y is the inverse of X. So if you find inverse of X and multiply by 10, it will give you 10y. And all the elements are compared, and I just have to find the corresponding element in the place of alpha. That's your answer. Yes or no? So let's go for that quickly. So how to find the inverse of this matrix? So far we have done many example. Okay, so what is the first determinant of this matrix? Let's find the determinant of this matrix. Which is the simplest row is the last row, right? I'll expand along the last. Even the first two I can try. 1 into 1 plus 3 minus of minus 1 into 2 plus 3, 5 plus 1 into 2 plus 1, 3. Right, this is our determinant of the matrix. So what we get is plus 3 plus 5. If everything is right, another plus 3, which has to be 11. Okay. I'm rechecking it again. 1 into 1 plus 3. Okay, this has to be 4, right? Yeah. 1 plus 3, which has to be 4. minus of minus 1 into 2 plus 3, 5, correct, plus 1 into 2 plus 1, 3. So this has to be now 4 plus 5 plus 3, which is 12, right? The determinant of the matrix is 12. Now coming to adjoint of this matrix. Adjoint of X is going to be transpose of cofactors. So again, what is the cofactor of this? 1 plus 3, 4, right? For this we already have, but it has to be minus 5 because we are going to put a negative sign. And cofactor of this already we have got here, which is 3, right? So next part here, if you want to find the cofactor of this number, to eliminate this row and this column, we end up with first column and second row, minus 1, which is minus 2, and what is the sign of this? This is second row, first column, so it will become minus of minus plus 2, right? Yeah. And eliminating this row and this column, we have 1 into 1, 1, minus 1, 0. Very good, because 0 means we don't have to worry about the sign. And eliminating this column and the second row, third column, we end up with 1 plus 1, 2, but minus 2 here because it is a second row, third column. So coming to the next one. What do we have? We have this 1. If we eliminate the first column and the third row, we end up with plus 3 minus 1. Yes, plus 3 minus 1, 2. What is the sign of this? Because it is the first row and the third column, it remains plus only. And coming to this second column and third row, which will be minus. Eliminating all this, we have minus 3 minus 2, which is minus 5. It will become plus 5. Coming to the last row and last column, let's keep the sign plus. So it is going to be 1 plus 2, 3. Transpose of this is our adjoint. Yes or no? What is the transpose of this? We have a lot to do. We are just in the midway. So it is 4 minus 5, 3, 2, 0, 5, 3 minus. Okay, so there is an error, right? What is it? We have to write the transpose, not the exact matrix, right? 4 minus 5, this is plus 2, 0, minus 2, plus 2, 5, plus 3, right? So now what will you do? It's X inverse you want, right? So we're going to divide this by 12. Okay, so instead of doing all this, I'll be just showing the solution better, so we can save time as previous question. Let me erase all this. Let's look at the solution. Yes. See, this has to be, okay, they have made it, they have solved it in a very simple way. Instead of solving all this, I can show you that as well. So they are told y is the inverse of x. So x into y is empty matrix. Okay. So now they are given 10y, right, in the problem. So to get this 10y, we're going to multiply 10 to, okay, this is a very simple approach. 10 is multiplied to the previous equation. If we multiply 10 to this, we end up with 10y into ex. As we can multiply scalar anyway, you can easily bring this. So now x is given already. The x has been multiplied with, yeah, this is the best approach because that solving a inverse is going to take a lot of time. X is already given and y, 10y already given. We multiply that. When you multiply that, we get the solution of a new 3. It's a 3 by 3 matrix. There's another 3 by 3 matrix, which will give you another 3 by 3 matrix. And all our focus is on the this part, alpha. Okay, so we end up with 0, and here we get alpha minus 5. So that's the only focus we want, but we have to write all the steps, right? So once you solve all this, we end up with comparison, corresponding element in the place of alpha minus 5, we have 0, or 5 minus alpha, or alpha plus 5. In every way, there are 3 equations you can see. 5 minus alpha is 0, alpha minus 5 is 0, and 10 is equal to alpha plus 5. In all the cases, the value of alpha will be 5 only. Okay, this is a interesting trick. You can use this if it is possible. If it is not possible, I mean, if that kind of trick is not working, we have to find the inverse, and that's again a tedious process. Okay, when this marking scheme is clear for us, if it is only 2 marks or 3 marks, you must understand there must be a shorter method instead of writing all the steps. Okay, so it depends. Right now, this is the best method. So there is already 10y given, and there is x given, and they said y is the inverse of x. So bring that x into y with the 10 between. Okay, so and then equate it. That will be better option, better way.